Hello, in this lecture we find out the value of the shaded area. In the drawing we have a circle. Inside this circle we have triangle ABC. Actually this circle blocks this triangle ABC. We know that side AB of this triangle equals to 13 units in its length, side AC equals to 15 units in its length, and this side BC equals to 14 units in its length. Our mission is to find out the value of this shaded area. It is very clear from the drawing that the value of the shaded area must be equal to the area of the circle minus the area of triangle ABC. Okay, so first of all, we will do a construction, that is to say from point A, we will draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A inside BC as M. Here side BC equals to 14 units in its length. So AM is perpendicular to BC. So BC in total equals to 14 units. So if we define side BM as X, then the value of side MC equals to BC minus BM. That is to say it is BC that is 14 minus BM that is X. So in total MC equals to 14 minus X. In the next step, we will implement the Pythagoras theorem on the right triangle AMB. So copy the right triangle AMB in a new page, and we will implement on this triangle AMB the Pythagoras theorem. We define side AM on this triangle AMB as H. So actually, this is the right triangle AMB that I copied from the original drawing. This is given as the equation that side AB equals to 14 units in itself, BM equals to X according to our definition, and AM also equals to 8 according to our definition. In this right triangle AMB, by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in this triangle AMB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared, this is equation number 1, equals to BM squared plus AM squared. So AB is 13, therefore AB squared is 13 squared, that is 169. This equals to BM squared. BM is X, therefore BM squared is X squared. Plus AM squared. AM is 8, therefore AM squared is 8 squared. We subtract X squared from this equation, and finally we get that according to this equation number 1, H squared equals to 169 minus X squared. This is equation number 1. H squared equals to 169 minus X squared. In the next step, I will copy the right triangle AMC on this new page, and we will implement on this triangle also the Pythagoras theorem. side MC equals to 14 minus x in its name. AM equals to age according to our definition. And side AC equals to 15 units in its length according to what is given as the question. So actually, this is triangle AMC that I copied from the original drawing. This triangle AMC by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in this triangle AMC, we'll get that AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225. And that is equals to AM squared. AM is h, therefore AM squared is h squared plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. Here we'll subtract 14 minus x squared from this equation. And this will be equation number 2. We get that according to equation number 2, h squared equals to 225 minus 14 minus x squared. This is according to equation number 2. While according to equation number 1, we have already found out that h squared equals to 169 minus x squared. In the next step, we'll create equation number 3. According to equation number 3, equation number 3 states that h squared according to equation number 1 must be equal to h squared according to equation number 2. So h squared according to equation number 1 is equal to 169 minus x squared. And it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So we will open the brackets on this side of equation number 3 and we get that according to equation number 3, 169 minus x squared equals to 225 minus, we'll open the brackets here, 14 minus x squared equals to 14 squared, that is 196, plus x squared, minus 2 times 14x is minus 28x. So according to equation number 3, we will get that 169 minus x squared equals to 225. We'll open the brackets here. So here we have minus 196 minus x squared. Minus and minus is plus, so it is plus 28x. So here we have a minus x squared on both sides of the equation, so minus x squared will get cancelled. So in this side of the equation we left only with 169. That is equals to 225 minus 169, it is 29. Plus 28x. Here we will subtract 29 from this equation, equation number 3, and we get that according to this equation, equation number 3, 169 minus 29 is 140. that is equals to 28x. Here we'll divide this equation by 28 and we get that x equals to 140 over 28 is 5. So x equals to 5 units. Now we can substitute x by 5 in equation number 1. According to equation number 1, we actually find out that h squared equals to 169 minus x squared. That is to say, it is equals to 169 minus x squared. X is 5, therefore x squared is 5 squared, that is 29. So h squared equals to 169 minus 25 is 144. So h squared equals to 144. We'll take a root out of this equation and we get that h equals to the square root of 124. The square root of 124 is 12. So I found out that h equals to 12 units. H equals to 5 and h equals to 12 units. Here, h equals to 12 units. H is actually the height of this triangle ABC. If the base is BC, if BC is the base, then the height is AM, because the height AM creates 90 degrees with the base BC. Okay. In the next step, we define the center of this circle as O. Point O is the center of this circle. We will join points A and O together by straight line. Point O is the center of the circle. Point A is the point on the circle itself. Therefore, OA is the radius of this circle. We will extend the radius AO by a straight line until it touches the circle. And we will define the touching point of the extended radius AO and this circle as point P. AP is a chord. AP is a chord of this circle, and the chord AP passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. So I can write down here that AP is the diameter of the circle. AP is the diameter of the circle. You know that the diameter of the circle equals to 2 times the radius. If the radius of this circle is capital R, then the diameter must be equal to 2 times capital R. So AP equals to 2 times capital R. So this is the diameter of the circle. Okay. In the next step, we will join points P and C together by a straight line. By joining points P and C, we created peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. Again, peripheral angle ACP rests on AP, that is the diameter of the circle. And we have a rule that says that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. It is actually rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. Here, AB is the diameter of this circle, and this peripheral angle ACB rests on AB. And therefore, this peripheral angle ACB that rests on the diameter of the circle must be equal to 90 degrees. And indeed, this peripheral angle ACB is equals to 90 degrees. Why? Because any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. So we can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, peripheral angle ACP, according to rule number 7, must be equal to 90 degrees. Okay, so this peripheral angle ACP must be equal to 90 degrees in its size, because it rests on the diameter of the circle, that is AP. Okay. Actually, we have another rule. That is actually rule number 8. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have chord AB. This peripheral angle ADB rests on chord AB, and this peripheral angle ACB also rests on the same chord AB. Therefore, they must be equal to each other. That is to say, if peripheral angle ADB equals to theta, then the other peripheral angle ACB that rests on the same chord AB, it is also must be equal to theta. Okay, so according to rule number 8, peripheral angles that rest on the same chord must be equal to each other. In this case, those two peripheral angles rest on the same chord AB, therefore they are equal to each other. That is to say, this angle equals to theta, then the other angle, this angle must be also equal to theta. We can implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle ABC. This peripheral angle ABC rests on chord AC. We have another peripheral angle APC that rests on the same chord AC. Therefore, they must be equal to each other. Those two peripheral angles must be equal to each other. Why? Because they both rest on the same chord AC. So if we define peripheral angle ABC as theta, then this peripheral angle APC that rests on the same chord must be also equal to theta. Okay? So actually we found out that angle ABN equals to theta. Angle AMB equals to 90 degrees. So if we focus on the right triangle, triangle AMB, this angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus theta. Likewise, we'll focus on the right triangle, triangle ACP. This right triangle ACP, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle, triangle ABM, is similar to the right triangle, triangle APC. So I'll write it down. The right triangle, triangle ABM, is similar to the right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So, angle ABM in this triangle, angle ABM, is equals to this angle, angle APC. Repeat again. Angle ABM in triangle ABM equals to angle APC in triangle APC. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AMB in this triangle, triangle ABM, angle AMB is equals to this angle, angle ACP, repeat again, angle AMB equals to angle ACP. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we can write down that angle BAM is equals to this angle, angle PAC, repeat again, angle BAM in triangle ABM equals to angle PAC in triangle PAC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that those two right angles are similar to each other according to angle rule. I write it down. The right angle, triangle ABM is similar to the right triangle, triangle APC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of triangle ABM over side AP of triangle APC is equals to side AM of triangle ABM over side AC of triangle APC. Repeat again, from the fact that triangle ABM is similar to triangle APC, we derive that AB over AP equals to AM over AC. AB equals to 13 units, over AP is the diameter of the circle that is equal to 2 times capital R, and is equal to AM. AM is 15 over AC. AM is 12. AM is 12. Here AM is 12 over AC is 15. In conclusion, we found out that 13 over 2R equals to 12 over 15. Here we'll cross multiply this equation and we'll get that 13 times 15 over 12 equals to 2R. Here we divide this equation by 2, and finally we get that R equals to 13 times 15 over 12 times 2. Here we divide both the numerator and the denominator of this expression by 3, And we get that r equals to 13 times 15 over 3 is 5. So in the numerator in total we left only with 13 times 5 over 2 times 12 over 3 is 4. So in the denominator in total we left only with 2 times 4. So in the numerator we have 13 times 5, that is 65. In the denominator we have 2 times 4, that is 8. So finally we found out that the radius of this circle, capital R, equals to 65 over 8. So I write it down. The radius, capital R, of this circle is equals to 65 over 8. Okay, I repeat again that the shaded area equals to the area of the circle minus the area of triangle ABC. I write it down. The shaded area equals to the area of the circle minus the area of triangle ABC. The area of the circle is equals to pi times the radius squared minus the area of triangle ABC. What is the area of triangle ABC? From the drawing it is very easy to see that the area of triangle ABC equals to BC, that is the base, times AM, that is the height, that is age actually. AM equals to age, that is 12, over 2. Repeat again. The area of triangle ABC equals to BC times the height, that is age, over 2. So the area of the circle is pi times r is 65 over 8, so r squared is 65 over 8 squared minus BC is 14 times 8, that is 12 over 2. So this expression, pi times 65 over 8 squared, in total it is equals to 207.394 square units minus 14 over 2 is 7, and 7 times 12 is 84. 207 minus 394 minus 84, in total it is equals to 123.394 square units. So I actually found out that the shaded area equals to 123.394 square units. Okay, in the next step I'll summarize the lecture. So in this lecture we found out the value of the shaded area in this drawing. In the drawing we have a circle. Inside this circle we have triangle ABC that is blocked by this circle. We also know that the length of side AC is for 15 units, the length of side AB of triangle ABC is 13 units, and the length of side BC of triangle ABC is equals to 14 units. Again, our mission is to find out the value of the shaded area. So first of all we did the construction, that is to say from point A, we do perpendicular on BC. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. Then I copied triangle ABM in a new page, and we implemented in this triangle ABM the Pythagoras theorem. Actually, we know that BC in total equals to 14 units. So if we define line segment BM is x, then the missing side MC must be equal to BC minus BM. That is to say, BC is 14 minus BM, that is x. So in total, MC must be equal to 14 minus x. So actually, this is the right triangle ABM that I covered from the original drawing. Side AB equals to 13 itself, side BM equals to x according to our definition, and side AM equals to h also according to our definition. So here by PT is the version from Pythagoras theorem. In this triangle ABM, according to the Pythagoras theorem, we get that AB square equals to BM square plus AM square. So AB is 13, therefore B square is 13 square, that is 169. And it is equals to BM square. BM is x, therefore BM square is x square, plus AM square. AM is h, therefore AM square is h square. So according to equation number 1, we found out that actually that 169 equals to x square plus h square. Here we subtracted x square from this equation, and finally we found out that h square equals to 169 minus x square. This is according to equation number 1. Then I copied triangle AMC here in the new page and implemented the Pythagoras theorem in this triangle AMC. This is triangle AMC that I copied from the original drawing. AM equals to h according to our definition, MC equals to 14 minus x as I already explained to you, and AC equals to 15 units according to what is given as the equation. In this triangle ABC by PT is a version from Pythagoras theorem. According to the Pythagoras theorem, in this triangle AMC, we get that AC square equals to AM square plus MC square. AC is 15, therefore AC square is 15 squared, that is 225, and it must be equals to AM square. AM is h, therefore AM square is h square plus MC square. MC is 14 minus x, therefore MC square is 14 minus x square. Here we subtracted 14 minus x square from this equation, and finally we found out that h square equals to 225 minus 14 minus x square. This is according to equation number 2, but according to equation number 1, we already found out that h square equals to 169 minus x square. So we have two different expressions for h square. Equation number 1 and equation number 2. Therefore, we created equation number 3 that states that h square according to equation number 1 must be equal to h square according to equation number 2. H square according to equation number 1 equals to 169 minus x square, and it must be equal to h square according to equation number 2. H square according to equation number 2 equals to 225 minus 14 minus x square. Then we open the brackets on this side of equation number 3, and we found out that 169 minus x square equals to 225 minus 14 minus x square. 14 minus x square equals to 14 squared, that is 196. Plus x square minus 2 times 14x, that is minus 28x. So here, we open the brackets here, we have minus before the brackets, so after we open the brackets, we get here minus 196 minus x square, and minus times minus is plus 28x. So we have minus x square on both sides of the equation, so minus x square will be cancelled. So in this side of the equation, we left only 169, that equals to 225 minus 196 is 29. So in the other side, in this side of the equation, we left only with 29 plus 28x. X square will get cancelled. So in conclusion, we found out that according to expression number 3, 169 equals to 29 plus 28x. Here we subtracted 29 from this equation and found out that 169 minus 29 is 140. So 140 equals to 28x. We divided this equation number 3 by 28, and finally we found out that x equals to 140 over 28 is 5. So x equals to 5 units in its length. Now we can substitute x in equation number 1 by 5. According to equation number 1, h square equals to 169 minus x square. But x is 5, therefore x square is 5 square. So So in total we get that h squared equals to 169 minus 5 squared, that is 25. 169 minus 25 is 144. So in conclusion, we found out that h squared equals to 144. Here we took out of this equation. And finally we found out that h squared equals to that h is equals to the square root of 144. That is, the square root of 144 is 12. So x equals to 5 and h equals to 12. So here you can write down that h, the h to the base BC edge equals to 12 units in its length. Okay, then we define the center of this circle as O. We join points A and O together by straight line. AO is the radius of this circle that is defined as capital R. Then we extended the radius AO by straight line until it touches the circle at point P. Chord AP passes for point O, and any chord, point O is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore, AP must be the diameter of the circle. Here, AP is the diameter of the circle, and the diameter of any circle is twice as long as the radius. If the radius is capital R, then the diameter AP must be equal to 2 times capital R. AP equals to 2 times capital R. Then we join points P and C together by straight line. In this way, we created peripheral angle ACP. This peripheral angle rests on AP, that is the diameter of the circle. And we have the rule that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. And therefore, this peripheral angle ACP must be equal to 90 degrees. Repeat again. We have here rule number 7, if a peripheral angle rests on the diameter of the circle, it must be equal to 90 degrees. Here, peripheral angle ACB rests on AB, that is the diameter of the circle, therefore peripheral angle ACB equals to 90 degrees. We implemented rule number 7 in our drawing. In our drawing, peripheral angle ACP rests on AP, that is the diameter of the circle, therefore this peripheral angle ACP must be equal to 90 degrees. Okay, then, so in triangle, then we have also rule number 8, according to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have those two peripheral angles rest on the same chord called AB. Therefore, they are equal to each other. So if this angle equals to theta, then the other peripheral angle must be also equal to theta again. Because of the fact that those two peripheral angles rest on the same chord called AB, they are equal to each other. So if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We actually can implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle APC that rests on AC. But we have also peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles, they are both rest on the same chord called AC, therefore they are equal to each other. That is to say, if peripheral angle ABC equals to theta, then peripheral angle APC must be also equal to theta. So if we focus on the right triangle, triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore this missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, if we focus on the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees, exactly for the same reason that this angle also equals to 90 degrees minus theta. Okay, in the next step, we proved that the right triangle ABM is similar to the right triangle, triangle APC. So why those two right triangles are similar to each other? Why the right triangle ABM is similar to the right triangle, triangle APC? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles that are both equal to 90 degrees, therefore they are equal to each other, and finally those two angles that are both equal to 90 degrees are theta, therefore they are equal to each other. So we actually succeeded to prove that the right triangle ABM is similar to the right triangle APC according to angle similarity rule. And from the fact that those two triangle ABM is similar to the right triangle APC, we derive that the following relationship exists between their sides. We derive that AB over AP is equals to AM over AC. Repeat again. AB over AP equals to AM over AC. AB is 13, AP is 2R, it is the diameter of the circle, AM is 12, and AC is 15. Here we first multiply this equation, and finally we found out that 2R equals to 13 times 15 over 12. We divided this equation by 2, and finally found out that the radius of this circle, capital R, equals to 13 times 15 over 12 times 2. Okay, here we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13, and we divided 15 by 3. 15 over 3 is 5. So in total in the numerator we were left with 13 times 5. We divided the denominator also by 3, so it is 2 times, we divided 12 by 3. 12 over 3 is 4, so in total the denominator we left only with 4 times 2. So 13 times 5 is 65, and 4 times 2 is 8. So in total we found out that the radius of this circle capital R equals to 65 over 8 units. Now after we found out the radius of this circle, it is very easy to find out the area of this circle. Repeat again, that the radius of this circle capital R equals to 65 over 8 units. What is the value of the shaded area? It is very easy to see from the drawing that the value of the shaded area equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared minus the area of triangle ABC. The area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is AM, that is H, that is 12 over 2. So pi r squared, R is 65 over 8, so R squared is 65 over 8 squared, minus BC is 14, times H, that is 12 over 2. 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC is 84 square units, and this expression in total equals to 207.394 square units. So 207.394 minus 84 equals to 123.394 square units. In conclusion, found out that the value of this shaded area equals to 123.394 square units. And that is the answer to the question. Okay, thank you very much.